Okay, I'm going to take a look at problem number 27, cryptography, right? And this is the science, cryptography is basically science of developing secret codes, okay? So the idea is that, you go through a process of what's called encryption, and encryption is basically taking your secret code, whatever that is, and basically hiding it, right? So no one else can read it except for the intended receiver of this message. So encryption is hiding that code, especially in some with some technique. There's a lot of different techniques out there, and decryption is the technique of using a key to actually extract that secret message or that secret code back. Okay. So the technique we're going to use in 27 is that it's a simple one. Basically, you use the first letter in each word to represent the secret message. Okay. So basic idea: you're going to write a program to read a data file and determine the secret message stored by the sequence of the first letters of the words. Okay. So we'll go and do that. Okay, so the approach I took was actually to take a look at is to use the author solution that I have defined. It's on the website, and I'm going to go through this and I'll put comments in it. That way you can relate right back to what the author did. My solution would be a bit different, but I'll follow the author solution. Okay, so the first part of this program, you just have your includes. Okay, here's the standard includes one. And there's one additional one here. I haven't covered this in the lecture slides yet, but it actually is part of this chapter. So, but there's not really much that this program uses with this. Okay. So you need this include when working with strings. And what's a string? A string is a sequence of characters terminated or ended, let's just say terminated, with a null character. Okay, special character, null character is just this. It's just a zero, but you would see it like this. Backslash 0. Okay, that's a null character. So it's just a sequence of characters with this special character at the end of it. All right, so a bunch of characters with that at the end. Okay, now the next thing it's done is define. You know what? I'm going to put it over here. Define what are called the white space characters. Okay, so when we put words, in our text file, we'll create a text file and put a few words in there. And when we put those in there, how do we distinguish between like the end of one word and beginning of next? You have a white space in there, so you're going to have a new line, a space, or a tab for that. Okay, characters. So these are this white space, meaning just not printable, right? Not printable, but specifying that there should be some space between, one word, number, and the next, right? Okay. All right. So those are white space characters. So these are the ones we're kind of looking for to determine that, oh yeah, we need to do the next word, right? Okay. So the next one is defining some variables. And this one here is going to be used to determine whether or not like you're not part of the word. In word meaning that you're inside of the word. You're looking at characters inside of the word that are not the first character. Okay. So I'm going to say use to distinguish if first letter of word, or maybe I should say determine. Use to determine if first letter of word. Determine if first letter of the word. Okay, so we're going to use that. So basic idea, if it's false, you're the first letter, right? If it's true, it's not. Okay. One of the things we need to do is we need to read in each character, one character at a time, okay, from our file, okay. So this is our character. So this is character read in. Okay, so that's what we're going to look at, each character, right? Now encrypted, this is just the name. We're going to use this for the, this is the input file stream or input file object name. Okay, so that's where we're actually going to use that to connect to the data file. All right, then the last one is the name of your data file. Okay, all right. Now typically we would hard code the file names in there. The author chose to, in this particular case, chose to prompt the user. Okay, so you prompt the user for the name of the data file, or the name, in our case, the message, or the text file. And so this one just prompt the user for the name of that file, enter the name of the file. So this is the name of file that has message encoded in it. Okay. So you got to be able to pull that message out. Okay. Then here is the actual opening, right? So they're doing what's called a dot C string. This will actually enter the name of the data file right in there. So whatever name you put in for iname, this one will extract that name and just use it. Okay. C. Okay, that's how you actually go and use it with this object. When you do a file stream, I'm sorry, not a file stream object. When you do a string, when you have this as a so-called object, this is kind of like when we did, dot get, where we're going to do it right here. It's the same idea. It's actually a function that's part of this object, okay? So really all you need to know about this is that you use it with this access operator, the dot like this, and this will actually give you the name of the file, okay? Really, it's just the name of the string. It really doesn't matter. You could, like in this case, I use it as, or in this case, it's used as the name of the file, but it could be anything, all right? But this is how you can get it. Name of the file, or the string name, or the name that was entered in for that, okay? Or the data that's contained in that string. Probably a better way to say it. Okay. So this one just checks. This is our file checking. Does file exist? All right. So in this case, you entered a name, but it was incorrect, right? That file name is not, it doesn't in correct location, I should say, right? Exist and incorrect location, right? Which is in the same directory as your CPP file. And this is what we did before. Just check to see if it exists. Okay. Now this one says basically get the first character from the file, right? So you're reading that first character to start. This is where you kind of kick it off. The next thing, this while loop, determine the message, but the while loop is for, I'll put this in here. You know, you can use, I'll use the single line. Loop to go through all of the characters in the file one by one. All right. So you're going through them one by one. And then you're going to do a comparison in here. All right. So the way the author used this thing called inward basically just keeps track. Like it says, oh, okay. So as it goes through, it checks. If it's not in the word, that means it's the first character, okay? If not already in word, this is first letter, right? Or first letter, right? So what it does then is it reads it in and says, oh, okay. And the idea is that when you first start reading a file, you want to look at the first character. First character is the beginning. You're assuming that there's no spaces or anything at the beginning. You're just starting with a word in your file. Okay. So this one says basically that, okay, if it's not in word, well, we set in word equal to false at the beginning. So the first character gets read in here, and then this starts, going through the process of reading all the characters in the file. This while loop goes through that process. Okay. So the first one gets read in, and then it says, oh, it's not in word. Why? Because we set it to false first. So it's not in word. So this actually evaluates out to true because this is the opposite. Then it reads the next character. It reads the character, not reads it in. It displays the character. So this just displays it. Okay, display character. And the reason we want to do that is we want to display our message, right? Our encrypted message. Then the next one says, okay, after you display that character, now set the in word to true, which meaning that now I'm in the word, right? So after displaying character, set the in word to true. Means essentially now inside a word, right? You're not the first character. Okay? All right. And then use a switch statement. Now the switch statement, basically, this is where the comparison happens, right? This one is check to see if you have a tab, a space, or a new line character, okay? Oh, let me move this down. This is your comparison. So the first one is a new line character. New line character, you're just going to read this in. So read in new line character. So you went to a new line. All right? And then you output it, the value. Okay, so what this is doing is just going and saying, oh, okay, I got a new line. I'll put the new line. I'll put the character. Okay, so this just outputs that new line, so brings you down to a new line. Okay, notice in here there's no break, right? So if you get a match of a new line, it's just going to display it. So put the new line out there, so you go down to a new line, and then tab and space, all of those make it false. Okay, so what it says basically is that you see a tab, you see a new line character, you see a space. Any of those things essentially means the next character that you read in, is going to be the first letter of the word. Okay, so the next thing that happens, so after you go through here, it sets in word to false. Okay, if there's a new line, tab, or space, you're going to set in word equal to false. Okay, then you go and read the next character. So if in word is false, meaning one of these things just came up, when you read this in, when you come back up again here, this will now be true. Okay, and then you display the character. All right, so you write it out to the screen. So this one just reads, this just goes next character, reads the next character. It actually says it right here, retrieve the next character in the file, okay? So because when one of these, if you have new line, tab, or space, any of those set inward to true, okay? So let me put that in here. Set inward to true, Oh, sorry, not true. False. False. If new line, space, or tab is encountered. Okay? And the only reason they do it here is just that if you have a file and it has, this keeps track, basically displays the new lines as they show up in your file. Okay? Okay, so then you read it in, then you go back up here. So this one just keeps going, right? Not encrypted.env file. We did this before in the files chapter, which basically means just keep going through this whole file. And then you end. Okay? Okay, so what I need to do now is actually go in and create the file. Okay, so I'll go and do that. My program is right here. So let me go inside here. I'm going to go find my source code. Okay, so here's the directory. My source code is in. I'm going to right click, new. This is how I'm going to do it. Text document. Okay, so I'm going to call it message. How's that? And by default, it'll put .txt in there. And here's my message. How elephants live partially. I don't need to put uppercase. I can put lowercase. It really doesn't matter. We'll just do that. So you can see the message there, right? Okay, so there's my file called message.txt. And I'm going to go, and I put that, like I said, in the same directory as my CPP file. Here's my CPP file. Shows up here. So I'm going to put it in the same directory as my CPP file. So just save it. And I'll go back to my code here. And I'll run it. Okay, and like I said, this code is in the solution set. So let me run it. Input file, message.txt. Oh, you know what I'm going to do? I could do Control F5, or I could just go down here. System pause. And notice that, we could have done, we could have created a character variable, and we could have done a, instead of a get, like this, .get, we could have used the, redirection operators to do, a cin. But the problem with the redirection operators is a redirection operator will skip the white space characters, okay? Which we don't want to do that. So if we want to look at the white space characters also, which is new line, tab, and space, we need to use a get. And that's why it's a .get to retrieve those next characters in the file, okay? All right, so let me go and run this again. And the only thing, prompt message.txt. And there it is. There's the message. Help. Okay? All right, and that is it. That's it for this particular program.